Okay, so now we're on the back here for part 2, and we've got some word problems, 6, 7, and 8. All right, so let's see what we can do here. Jason jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t, this is important, equals negative 16t squared plus 16t plus 480, where t is the time in seconds, h is the height in feet. Jason hit the water after how many seconds? So what we're trying to find here is time. That's what we're trying to figure out. Now, if you graph this, Jason jumped off a cliff and he hit the water here. And what we want to find out is how many seconds did that take? So what we're really looking for is the x-intercept, or where the height is equal to 0. So we're going to take this function. Now, instead of plugging in numbers for t, we could do that and kind of guess, but what we're trying to find out is when is the height 0? When is the outcome 0? So I'm going to write an equation here. 0 equals negative 16t squared plus 16t plus 480. Oh, and now we want to solve it. We want to find out what value for t gives us a height of 0. Now, before I start factoring, I know that the lead coefficient is greater than 1. So I can multiply those together and I can try to come up with my correct combination of factor pairs. But before that, I noticed that all three of these numbers are divisible by 16. So what I'm going to do is take both sides of the equation and divide by 16. I'm going to make this simpler. And actually, I'll divide by negative 16 because that will then make this positive. So we get 0, 1t squared minus 1t minus 30. Okay, each number gets divided by negative 16. Okay, so here we go. We've got a trinomial. The lead coefficient is 1. 1 times negative 30 is negative 30. So can you think of two numbers that give you a product of negative 30 and that add up to the middle number, which is negative 1? The number that jumps out to mind, the pairs 5 and 6. Now, to multiply to a negative, though, one of these has to be negative. And because we have to add up to a negative 1, let's make the negative the 6, because 5 plus negative 6 is negative 1. 5 times negative 6 is negative 30. So we can go to our parentheses, because it's a 1t squared. It's t plus 5 times t minus 6. And now that we factored it, we're not done. Now we need to solve. So what we do is we take each factor, set equal to 0, and we solve. Here we would subtract 5, so t is negative 5. Here we would add 6, t is positive 6. Okay, now we've got to think here. Jason is jumping off of a cliff. He hits the water. According to this, there are two solutions. He hits the water when t is negative 5. He hits the water when t is 6. Now the t represents time. Is it possible to have a negative amount of time, to have negative seconds? No, it's not. So we are going to ignore the negative answer in this case because it doesn't make sense in the context of the problem. So even though that is a solution, it's not the solution to this problem. So we only have one answer. How many seconds does it take? 6 seconds is when he hits the water. Right there. If you were to graph this accurately, you would get 6, 0 as your x-intercept. That's the other way you can do it. All right, let's take 7. The length of a rectangle is 4 inches longer than its width. Find the dimensions, that's length, length and width of the rectangle if its area is 96 square inches. Well, they're talking about rectangles. Let's go ahead and draw a rectangle. Area is length times width. That's the formula. But they tell us the length of a rectangle is 4 inches longer than its width. W is for the width. The length is 4 inches longer than the width. So that means 4 more than. W plus 4. So what I'm going to do, I don't want two variables in this. I only want one variable. So instead of using L, let's substitute W plus 4, which is the same thing. The length is 4 inches longer than the width. Okay, so we do length times width equals area. So we're going to make an equation. Oh, don't want to do that. So W times W plus 4. So here's length, here's width. When you multiply them, you get your area, which they tell us. They tell us the outcome is 96 square inches. Square inches is just your unit of measurement. Okay, so it's not 96 to the second, it's inches to the second, which has nothing to do with the numbers. Okay, length times width equals area. Okay, now this is a case we are going to distribute this first. W squared plus 4W equals 96. Now when we solve a quadratic equation, we want this equal to 0. So let's move the 96 over. W squared plus 4W minus 96 equals 0. Well, how do we solve a quadratic equation? Let's try to factor. It's a 1W squared. So on the side, 1 times negative 96 is negative 96. So what multiplies to negative 96 and adds up to 4? 96 has a lot of factors. 1 and 96, that's too far apart. 2 and 48, 3 and 32, 4 and 24. 5 doesn't work. 6 and 16, well, it's getting closer. 7 doesn't work. 8 and 12. Oh, look at 8 and 12. They're 4 apart. Okay, now to multiply to a negative 96, though, one of these has to be negative. To add up to a positive 4, the plus has to be the 12 and the minus has to be the 8. Negative 8 plus 12 is 4. Negative 8 times 12 is negative 96. There's our winner. So what we get here is W minus 8 times W plus 12 equals 0. Take each factor, set to 0, and now you solve each equation. Now, we're just going to add 8, so we're going to get W equals 8 as one answer, and here we would subtract 12, we would get W equals negative 12. Now remember, we're talking about length and width. We're talking about a rectangle. You can't have a negative length or a negative width. So this doesn't make sense. We're going to cross out that choice. The question is, well, they want us to find the dimensions. So we need the length and the width. Here's the width. So to find the length, go back to your picture, and we're going to substitute 8 for W, because the length is 4 more than the width. So 4 plus 8, or 8 plus 4, we get L is 12. So our dimensions, width equals 8 inches, length equals 12 inches, and as a check, length times width, that is 96, so that works, and the length is 4 more than the width. Okay, and that's how we do that. So the challenge on these word problems is you have to come up with the correct equation to figure out what to solve. Once you have the equation, now you're just solving by factoring. All right, now I'm going to show you one more type of problem here, number 8. Write a quadratic function, that's ax squared plus bx plus c, that has a graph that contains the points negative 2, 0, 4, negative 12, 5, 0. What they're actually telling us, they're giving us two of the solutions, the two solutions to the equation. Because remember, when we solve, like we just did on the last problem, we set this equal to 0, and then we solve the equation. So in a function, the solution is ax squared plus bx plus c. Whatever values of x make this equal to 0 is what we want. Now, when the y value is 0, those are the solutions. Those are the x values that make it happen. So we actually have two answers. We have x is equal to -2, and we have x is equal to +5. So what we're going to do is work backwards. We have the answers. What we need are the factors. So normally, we take the factors here, and we set them to 0. We got w equals 8. We had w is -12. What if I wanted to go back to the two factors? So if the answer is +8, to move it back, I would subtract it, and I would get w minus 8. If the answer was -12, I would add it to get back, and it would be w plus 12. So if the solution is x equals -2, I would add to both sides to get x plus 2 equals 0. Here, if the solution is -5, the factor would be x minus 5. And what's happening, we multiply the factors, and we get the answer is 0. Now, there's one more piece to this, though, that we want to figure out. And there's some coefficient. There's probably a number in front of the x. Okay, if I double distribute here, then I'm going to get my quadratic, but the problem is I'll only get a 1x squared. There's probably another number here, a lead coefficient. So notice that they give us two solutions, two x-intercepts, but they give us a third point. They give us 4, -12, which is an x and a y. That means if we substitute a 4 for x, we should end up getting a -12 for y. So right now, here's our function. We have f of x equals a times x plus 2 times x minus 5. Okay? But what I know is that if I substitute, I don't know what a is, but if I put a 4 in for x, my answer, the y value, has to be equal to -12. So what I need to do is solve one more equation here. -12 equals a times 6. 4 minus 5 is -1. 6 times -1 is -6a. We're going to divide to solve for a, and we get +2 is equal to a. So the function, I'm going to write it one more time, f of x equals a times x plus 2 times x minus 5. That's the function in factored form. Okay, if I set it equal to 0, if I wanted to solve it, this factor would give me -2. This factor would give me +5. Now, the last thing we'll do here, this is technically good, but if we want to write it as ax squared plus bx plus c, we actually have to double distribute. So I'm going to do that. So we have the 2 on the outside, and then x times x minus 5 is x squared minus 5x, and if I distribute the 2, we get plus 2x minus 10. X squared, this would be minus 3x minus 10. And then last thing I would do is distribute here. 2x squared minus 6x minus 20. That is the function. Write a quadratic function that has a graph that contains these points. Now let's see, just to check here, y equals 2x squared minus 6x minus 20. Now it looks like the zeros, the solutions are at -2, 0, 5 comma 0. And does it contain the point 4 comma negative 12? 2, 3, 4. Well, I'd have to go down 12. I'm going to go to the table here. Oh, first I need to set it up as... Okay, I know that what I'm doing on the calculator you're not familiar with, but that's okay. If you use Desmos, x is 4, y is negative 12, x is 5, y is 0, x is negative 2, y is 0. So everything fits, and that is the end of part 2.